In this problem, we're asked to solve for the displacement if a man runs for 75 minutes with a velocity of 5 meters per second north. So let's solve this problem. First, I'm going to draw out what the scenario is. So we have a person who starts at a point and they end at a point. We'll call it x1 and x2. Now the difference between these points is our displacement, delta x, which we do not know. We don't know the magnitude of this displacement. We know he's walking north. He's got a velocity of 5 meters per second north. And so the direction of the displacement will be in the north direction, but we don't know the magnitude of that displacement. Now we know the time interval he walks this. So x1, well, I'll do this. He starts at a time of t1 equals 0 seconds, and he ends at a time of 75 minutes. Okay, and then the final thing we know is that his velocity, which is his average velocity, assuming he doesn't walk at a constant speed the whole time, 5 meters per second. Okay, so now we can use our velocity equation, where our average velocity is our change in distance over our change in time, which is just x2 minus x1 over t2 minus t1. I'm going to not use this form, and I'm just going to use the delta form. So we want to solve for displacement, so we just multiply time to the other side, and our displacement is equal to our average velocity times our change in time. So our change in time is 75 minutes, our velocity is 5 meters per second, and so we have everything we need to solve. Before we do so, notice that this is in meters per second, so we have a time unit of seconds, and here we have a time unit of minutes. And we need this to be same. So I'm going to convert the time to seconds before we solve this problem. So delta t is equal to 75 minutes. There are 60 seconds in 1 minute, so those units cancel. And 75 times 60 is, we get our delta t is 4,500 seconds. So now I'll plug this in for delta t instead. So delta x is equal to our velocity of 5 meters per second times our time of 4,500 seconds. And that gives us displacement of 22,500 meters. Or, if you want to convert to kilometers, 22.5 kilometers. Now, we need to add a direction to this. So this is like our magnitude. Time is a scalar, velocity is a vector, and so a vector times a scalar is a vector. So if I wanted to write, let's say, we call this the positive y direction, so plus y, or in our unit vector notation, this would be j hat. I could write that delta x is equal to 22.5 kilometers j hat. So because our velocity is a vector, this could be j hat here. Then this would not be a scalar anymore. So the j hat direction times the scalar is still in the j hat direction, and we get this final answer of 22.5 kilometers in the j hat direction or the north direction. So that's how you solve this problem. Thanks for watching.